Okay, algebraic expressions. Here we go. Got to be able to learn how to add, multiply, add, subtract, things like that. If we add them together, we add like terms. 3x squared and 5x squared make 8x squared. 2x and negative 10x make negative 8x. Negative 5 and negative 9 make negative 14. As you have problems like this on your test, you should say, thank you, Mr. Gens. These are ones I can feel confident with and I know I will get. So these are the give me points. So we trust that. If you see them multiply together like that, we take each part of the first polynomial and multiply it by each part of the second polynomial. So we have 8x squared plus what? 28x. Then what? Minus 4x minus 14. Can we combine the middles together? Yes, we can. They are like terms. So 8x squared plus 24x minus 14. And you remember back in 8th grade or 9th grade, you spent 2 days doing those, right? It's like, or 3 days. Like you had a test just on that. Okay, we're done. So that's knowledge that we hopefully remember and we can work with. So we'll give you a little bit more challenging ones. I don't want you to do D, but I want you to do C, E, and F. Go ahead and give those 3 a shot right now. These should be reviewed from the past few years, and I should feel confident about them. Do I have these right, or did I make a mistake? Okay. All right, so what's the mistake that people will generally make with letter C? Yeah, the negative. They forget the negative, and if the negative doesn't go through, then you're going to get the wrong answer. So remember, this is a negative 4, so distribute accordingly. 6x, I'm sorry, 3x minus 4. If you square that, a lot of people write 9x squared and plus 16. You forget about the middle, so make sure you do so you get the middle. And here you distribute through. Generally, no mistakes there. So let's look at letter D. First, well, before that, any questions on C, E, or F? Okay, letter D. Oh boy. What to do, what to do, what to do. What do you want to do? Good. X to the 3 halves. 2x to the what? 1/2. Very good. Minus 3x to the 5 halves. I had a class last year, they always get mad at me because I would, you know, I'd wait for an answer and then somebody would I'd say, yes, good job. They're like, I said that. Why didn't I hear you? So you gotta speak up, right? The loud voice. Let me know. X to the 3 halves times 2x to the 1/2. I have to distribute that through. When I distribute, what do I do to the exponents? Which is it? I add. And if you don't remember, make an easier problem. X to the 3rd times 2x squared minus 3x to the 5th. Okay? There you would have an x to the 5th and an x to the 8th. So you reminded yourself. You said, oh yeah, I add them when I do that. And so I have fractions here. I'm going to add them together. Do I have common denominators? I do. This becomes 2x to the 4 halves, which is 2, minus 3x to the 8 halves, which is 4. Very good. Now, you're going to have a problem similar to that in your book and on your study guide and your tests and stuff. And I promise you that you need to check to make sure you get that right because there's a lot of mistakes that can be made with those type of problems. For example, if this was a cubed root, a lot of people would make a mistake there then. Trust me. And so I'll just let you find out. You got to find out on your own as you do the problem. So, all right, flip it over. This is what you love. You love to factor deep down inside. You do. You love it. It's okay. This is the time of your life you need to embrace. You're a math nerd. You are. You are. Jack, don't fight it. Embrace it. If you can't get out of it, get into it. Love it. Yep. How many people, come on, how many people take 7 college credits in mathematics their senior year? Not many, or their junior. Not many. So you're kind of up in that upper echelon. You need to just embrace. I'm a math nerd. I'm okay with it. It doesn't make me less cool. I'll still get a date for prom. All is good. All right. So, what is it that you really love about math? A lot of you really love factoring. You're like, yeah, I loved that stuff. So let's practice it. Yeah. See, I see it. Head nodding right there. Right. Love factoring. Difference of two squares. It's like, thank you. Yep. All right. Let's do it. We always first rule of factoring, we always look for a common factor. What can you take out? A 2x squared. And you're left with 2x minus 3. Boom. Done. You try B. Go. Greatest common factor. Okay, what's the mistake that sometimes people make with B? They forget the 1. Got to remember the 1. If you were to distribute it back through and multiply, you got to make sure you get the 3y. And if you didn't write the 1, you wouldn't get the 3y. Okay? So that's what's nice. You can always, there's always a way to check in math. Okay, then sometimes you don't have greatest common factors. We don't have greatest common factor. Well, trinomials. I remember the problem we tried on the other page. We ended up with a trinomial, didn't we? We took two binomials and multiplied them together, and we got a trinomial. So I bet this trinomial comes from two binomials. In fact, what times what gives you x squared? X. What two numbers multiply negative 33 that add to negative 8? Negative 11, positive 3, done and done. A lot of people will do this. Does it say to solve? Is there an equal sign in this at all? So don't solve it. Just as factor. It's factor. Okay, D. X and X, what two numbers multiply to 48 that add a negative 13? Six and 8, 16 and 3. You know, you can list them all off. We got 12 and 4. So I picked this one because it's harder. A lot of people don't see the 3 and the 16, but it is 3 and 16. The minus goes with the 16. Plus goes there. Okay, well, what if the front coefficient isn't 1? Because those were pretty straightforward. You guys remember those. But what if we got an 8? Ugh. Common factor? No. Well, you got two options, guess and check or AC. I'll do guess and check first. I need two things to multiply to 8x squared. You got 8x and x or 4x and 2x. I'm going to try the 4x and 2x. And you might say to yourself, how do you know? You don't. It's called guess and check. You're guessing. You're guessing. So then, well, 3 is nice because it's either got to be 3 and 1 or 1 and 3, right? And it doesn't add up to the middle. It's just that you check the inside and outside and you get the middle. So let's see, 4 times 3 would give me 12. That's too much. So let's do a 1 there and a 3 there. So I get 6x and 4x. Hey, 10x. Right? Okay. So if we have letter F, that's a different scenario where we're going to teach you the AC method. I do the AC method different than Miss Nelson. Why? She's smarter than I am. I can't keep up with her mathematics. So here's how I do it. You have ax squared plus bx plus c. The AC method says we take the front coefficient a and we multiply it by c. And I write my new trinomial. X squared plus 7x minus 8. Are you okay with that? Didn't lose anybody yet, right? We're all good there. Now here's what I do. When I factor it, I leave space in front of the x's. What two numbers multiply negative 8 that add to 7? Plus 8 minus 1. Correct? I leave space in front of the x because I'm missing my 2. I mean, look at the beginning. You got to get a 2x squared. So either the 2 goes there or it goes there, correct? So I put the 2 back in. Can you take a common factor out of 2x and 1? No. Can you take a common factor out of 2x and 8? What can you take out? So take out the 2. What are you left with? X plus 4. That's how I do it. I insert the a back in, and I look for the common factor. There's about 5 different ways to do the AC method. I never learned it. I mean, I learned it my 3rd year here. A new teacher came and said, yeah, when I was in high school, I did the AC method. And we're all like, what is that? And so then they showed us. So that's the version that I've learned that I like. Miss Nelson's does something with like dividing. So what do I do? 8 over 2? 8 over 2 is the 4. Oh, is 4 over 1. So the 4 goes there and the 1 goes there. And then this one is 1 over 2. So the 1 goes there and the 2 goes there. Whatever. I like my way. Okay, and we get difference of 2 squares. Difference of 2 squares are really nice. Probably the best factoring type problems. What multiplies 9x squared? 3x and 3x. So multiplies y to the 4th. Y squared and y squared. And then what? Y. Tell me more. Noah. Yeah, so the whole idea is that those are opposite those, right? And so they'll cancel out. That's why you get no middle, right? That's the beauty of it. So we do the next one. X to the 4th minus 1. What do you got? X squared, 1 and 1, plus and minus. Done? Ooh, why not? That factors? Does that factor? Why not? You watch this, because you guys need to understand this at your age, and there's many people that still don't get this. Watch. X squared minus 1. It's a graph. What shape does it make? Starts with P. Parabola. Shifted down how many units? 1 unit. So it crosses the x-axis at -1 and at +1. This parabola shifted up 1 unit. Does it cross the x-axis at all? No. That's why it doesn't factor. It doesn't factor in a real sense. You can factor it in an imaginary factoring way, but it doesn't factor to any real numbers. Period. This does. And there it is. X minus 1, X plus 1. Sum of 2 cubes. Some people are like, well, why does the sum of 2 cubes factor, but the sum of 2 squares doesn't factor? Well, a cube looks like this. It's shifted down 1 unit. Does that cross the x-axis? Yeah, 1 spot. It factors with 1 binomial out front. This one is shifted up 1 unit. Does it cross the x-axis? Yeah, right there. So graphically, you can understand why they have solutions and some don't, right? And that's when your mathematics really starts developing, when you can see any algebraic expression starting to connect it to the graph. All the calculus students, they were told at the beginning of this year, they need to know how to graph anything, and they need to know how to solve any equation. And when you can tie the two together, you become much more efficient and effective and dangerous. So, let's do it. So for the record, this does not factor. So we just leave it x squared plus 1. This does x plus 1, x minus 1. Done. Okay, cubes. Got to write down the formulas. You will not be given these on the test. You have to remember them. And I will show you how I remember them. How you remember them is up to you. But you will, because you are excellent. Best of the best. Super smart. just told you why sum and difference both factor. We looked at the graphs. What a beautiful day. It's a good thing we're sitting in here. Okay, so here's what I do. I identify what is A and I identify what is B. A is whatever you cube, and B is whatever you cube. What do you cube to get x to the third? X, what do you cube to get 8? So this is the difference. So it starts off just like this looks. So it's going to be x minus 2. All right? Times, then I set up a trinomial. And here's what I do. I square the front and I square the back. Let me give you square the front. Square the back. Notice that the last term is always positive, isn't it? So I'll put a plus there. Now I just have to think about the middle. The middle is the 2 multiplied together. So I multiply these 2 together and I get 2x. What do I do for a sign here? It's always opposite that. And that's how I remember it. You might be like, well, that was too confusing. I didn't figure out your own way. I don't know. That's the way I do it. I'll do it once more. What do you cube to get 2x to the third? 2x. What do you cube to get y to 6? I squared. Okay, this is plus, so it's 2x plus y squared. Then I square the front, I square the back. Square the front, what do you get? 4x squared, square the back. Y 4. That's always plus. For the middle, I multiply the 2 together. When you multiply 2 together, you get. And this is always opposite that. That's how I remember it. How I do it. Flip it over. 4 problems left. Grouping, grouping, grouping. Another tactic. Here I have 4 terms. X to the third plus 5x squared. And I'm going to write it as plus negative x minus 5. And I'm going to put some parentheses right here. Okay. Can you tell me what is the value of this 5 right here? Is the value positive or is the value negative? The value is negative. You see the negative sign. But, watch what I do here. And the value of this 5 is negative. Watch this. I'm going to put my parentheses down. What's the value of that 5 now? Why? Because it's negative up front. You can't slap a parenthesis down in front of a subtraction sign. It's totally illegal because you change the value of everything behind it. Don't do it. Bad things happen. So I change it to plus, so then I can go about my business. Now, what can I take out of the first 2 terms? X squared, and you're left with x plus 5. What can you take out of the second set? Negative 1. And you're left with x plus 5. All right, now I have 2 terms. 2 terms. What do they share in common? They share x plus 5. When you take out an x plus 5, what are you left with? Am I done? No, now you have the difference of 2 squares. Favorite. Woohoo. Done. Anybody really like to read here? Like you're a big reader. Like you love to read. All right. L. What is the first rule of factoring? Take out A. Here's not factor what it is. X. So we take out the X. 3x third plus 6x squared plus 7x plus 14. Uh-oh, I'm going to have parentheses inside of parentheses. What can you take out of the first set? 3x squared. What are you left with? 2. Plus, what can you take out of second set? 7. Left with x plus 2. Cool. What can you take out of both of these? That's it, right? Got it? Okay. So, oh, here? Question? Gotta ask it. Then we just identify the steps. Did you see how I got here? Okay, so then let's do that last step. I have my x. Actually, let's just pretend like the x wasn't there at all. And do you agree that in the end, the x needs to multiply everything? So, what can we take out of both of these? X plus 2 from each one. What are you left with here? 3x squared. What are you left with here? 7. And remember, x needs to multiply everything. That was what we took out from the very beginning. From the very beginning. All right, good question. All right, these two are where you might get it, you might not. Okay, like 50% maybe. I have no idea what happened. Might have to watch the video again. Okay, these are tough. Not everybody gets them. So, I'm going to do it on a separate page, just because I'm going to need a little extra room to show you guys. So we got negative 2/3, and we got an x. And then we got 1 plus x to the 1/3. Is that correct? Okay. All right, so this is the problem we're going to do. Now, when you encounter difficult problems, sometimes maybe you want to try to do the easier problems, okay? So I'll literally show you what I want to try to do. If you look at, say, x to the third plus x squared, and you were going to take out a common factor, what would you take out? X squared. You don't take out x to the third. You take out the smaller one, right? And when you take it out, you're left with x plus 1. Because you did 3 minus 2 was 1, and 2 minus 2 was 0, which gave you x to 0 or 1, correct? So we subtract our exponents, and we take out the smaller of the two exponents. Okay, let's try a slightly more difficult problem. Let's say you have this. Y to the negative 2 plus y. Factor it. What is the smaller of the two exponents? Negative 2 or positive 1? Negative 2 is smaller. It's further to the left on the number line. So we take it out. Y to the negative 2 times, okay, we subtract. What's negative 2 minus negative 2? 0. So you get y to the 0, which is 1, right? We knew we were going to get a 1, right? Okay. Plus, the exponent is 1. What's 1 minus negative 2? So we end up with 1 plus y to the third over y squared. Now, you can factor that as that's the sum of two cubes. But you get the idea? Now, let's try the real problem. See how you guys handle this. I didn't try this example last year, so this is my first time trying it, so we'll see. All right. What's the smaller of the two exponents? So I'm going to take out a 1 plus x to the negative 2/3. What are you left with? What's negative 2/3 minus negative 2/3? 0. and anything to the 0 power is 1. So we have 1 times x. So I'm left with that x. Everybody convinced by that? If I multiply this through to there, I get this expression. Okay, now let's do the second part. 1/3 minus negative 2/3. 1, right? 1/3 minus a negative 2/3 is 1. So I get that thing, 1 plus x, to the 1 power. Here's where I lost people. Okay. Do I have to have that 1 there? Do I even have to have those parentheses there? No. I can combine these terms, can't I? I mean, what's x plus x? 2x, right? So I've got 1 plus x to the negative 2/3 times, I'm going to combine my like terms, 2x plus 1. Can I leave the negative exponent? No. 2x plus 1 over 1 plus x to the 2/3. So this problem here factors like that. If you didn't get it, watch the video again tonight and watch it through. Sometimes it takes more than once. That's a little bit new, huh? Huh? It's okay. You're not going to have a test full of problems like that, but you might want to be ready for one. All right, last problem. This one. I'm going to use space over here. Looks confusing, doesn't it? No negative exponents though, right? I don't know how to do the problem, so I'll make one that's easier. This part right here totally messes me up. So I'm going to replace it with something. I'm going to replace it with y. So it'll be y squared minus what? 2y minus 3. Oh, that's easy to factor, isn't it? That's y minus 3 times y plus 1, right? Well, so instead of y, what should I put for this part? A squared plus 2a. You guys agree that these are the same problems, just this one has an a squared plus a 2a, right? So we'll do that. I have a squared plus a 2a. A squared plus a 2a. So remember, that's like my y times y. Y times y gives me what? Not a trick question. Y times y gives me y squared. A squared plus 2a times a squared plus 2a gives me a squared plus 2a squared. So I got that part, right? Now, what are two numbers that multiply -3 but add a -2? -3 and +1. Oh, but we're not done, are we? This is a squared plus 2a minus 3 times a squared plus 2a plus 1. Can that factor? It's just a trinomial, isn't it? What does it factor to? A plus 3 times a minus 1. Does this factor? So what? A plus 1 times a plus 1 or a plus 1 quantity squared? Now it's completely factored. How's that? Raise your hand if you were at least slightly confused on either one of those. Come on. There you go. Yeah, all right, yeah. Oh, because what happened? smart smart board is the dumb board. We just do stuff that's too difficult. Smart board is like, I'm done. Shut down.